সেক্ষেত্রে ছোট না বলো। Zoom meeting meeting जाना है हाँ
अच्छा करणो sound नहीं मन पल्ले लदी
Hello. Yes.
क्या sound नहीं पड़ा
pre nakan chupo
Hello, is this audible? Hello?
Yes, sir. Yes, sir. It is audible now.
Good. Thank you. Sorry for the delay. So let me just see the chats. Also, those who are interested can directly unmute themselves and ask questions. So this is a doubt clearing session for Sustainable Energy Technology course. So I see several people in the queue. So anybody who is interested in asking any questions or clarifying anything that they did not understand in the course, please feel free to ask me. And I will try to clarify the doubts as much as possible. You can also put your questions in the chat box, and I will also read out the chat box and ask you, clarify the queries that way. The members who have joined, if you are interested, you can also introduce yourselves and tell me your interest in the course and what you want to get out of it. Hi, Wajid. So your question is inclusion of wave and tidal power as being part of the course possible since they are also renewable source of energy? So the 12 weeks is kind of a limited time to cover everything. So I have dropped wind and tidal power from the NPTEL version of this course. However, if you are interested in knowing a little bit about that, I can give you some sources. What you can do is just put a query in the group chat, and there I can attach some sources and point you to something, some of these. Mostly because I have dropped them because they are still a small part of the renewable energy. And so as being less important, I kind of dropped them. But of course, those who are interested in the technology, they will be interested. So I can give you some sources for you to learn. And if you have some questions, you can get back to me through the Google group chat. So just drop an email in that Google group chat requesting for these resources, and in a few days I can answer that. Maybe by Monday, Tuesday, I can give you a few resources that you can look at. So Vaishnav, your question is, during the summer, the northern hemisphere, all latitudes receive approximately equal amount of insolation. So here, insolation basically means the amount of solar energy they're receiving on average on a per day basis. So the reason is because the summer hemisphere is inclined towards the sun. So the number of daylight hour is increasing as you go higher up in the latitude. So above 66, 70 degree north latitude, the number of daylight hours can be even 24 hours a day. So what happens is, if you look at the equator is still receiving 12 hours of daylight. And that daylight is nearly normal to the ground. Okay. So in terms of watt per meter square, yes, equator is still receiving higher amount of energy in a given second during the daytime. However, as you go higher up in the latitude, despite the increasing inclination of the sun, the amount of daylight per second is reducing, but the total daytime is increasing. So as a result, that compensates significantly the total amount of energy that is being received. So over an entire 24-hour day, what happens is the solar insolation, even at high latitudes, approach that of the equator for the summer hemisphere. So the final exam, we will be covering we will be giving approximately equal weightage to all weeks. So each week will be featuring reasonable weightage. Okay, so if you have seen the weekly assignments, there are from each subject area covered in each week, we are giving equal weightage. There may be a little bit of marks difference here and there, but we have always tried to give equal weightage for every section and subset. No, it is not going to be an open book exam. I am sure NPTEL will clarify all the exam details to you. It will be a closed book, closed notes exam. Short numerical questions and objective type questions, similar to what you are getting in your weekly assignments, but not open book. Hello, who is speaking, please? Aminity, are you trying to open the video?
Her mic is on and it's like.
Can you mute her? Maybe. NPTEL team? Vamshi? Can you mute the participant whose mic is on? Okay, I have unmuted her. Okay. Amit Kumar Yadav is saying, oh, hold on, I missed a few chats. How to prepare for exam. So if you do the assignments well, as well as look carefully at the course notes, that should be sufficient for you to prepare the exam. Questions will be quite similar to what you are getting for your weekly assignments. The only difference is it's a closed note exam. So the basic concepts and some simple formulas you will have to remember a bit. Okay. So try to do the weekly assignments without looking at your notes. You read the notes, review the notes, then do the weekly assignments without looking at the notes that are there. That would be a good preparation for the final exam.
Since 9 weeks have already gone,
yes,
and if you want to revise those things, what is your kind of approach? Like, what is your suggestion on those?
See, different people have different ways to prepare, right? So what I would suggest is you make small, like personally, I would say you make small cheat sheet like notes where you can revise and try to see if you understand the concepts properly. And that often helps in like remembering the main concepts and the basic formula.
Okay, because see, we are working, most of us must be working people, and then it's very difficult for us to, in fact, go through the weekly classes and then give the assignments. But that anyway, it's a mandatory when we are going ahead with that, and we have to do that. But now remembering these things, say 12 weeks, we will be remembering those things and then putting it into the paper. So you said that we also need to remember the formula. So that would be
some of the basic formula that were part of the weekly assignments. Those
Yeah.
things you try to understand and the basic concepts. Okay. A little bit of review is necessary. I understand that many of you will be working and won't have sufficient time. So of course, this is a kind of your grading will be comparative with each other. So try to do as much as possible. What I can assure you, if you are working with reasonable amount of sincerity, then you should be able to do some of them and do reasonably well in the exam. So we don't expect everybody to get 100 out of 100 everywhere. So we know that doesn't happen. And in the previous courses also, that is not how it works.
Yeah.
So try to do as much as you can. Numerical sections will be only a part of it. A lot of it will be conceptual, as you know from the weekly assignments themselves.
Okay.
Try to recall as much as possible. If you don't, leave the question and do something else. Okay.
We are looking for passing marks, sir. That's all.
That you should be able
Yeah.
to get reasonably easy.
Okay. Thanks a lot. Yeah.
So the formulas for the numerical questions will not be given, since we are giving very basic questions. Just the basic formulas in each concepts that have been maybe covered in the weekly assignments that you should try to recall. So the idea is that you also should be able to get something. So if suppose somebody asks you to quickly derive something in efficiency of, say, solar energy or something like that, you should be able to recall some of the formula so that you can quickly give that answer. Right. So that is why we are not giving the formulas, because if you give the formula, it's just a multiplication problem for you. That is not something I want.
Sir, can I ask a question, sir?
Yes.
Good evening, sir. My name is MS Kishore Kumar.
Yeah.
I'm working as a principal in Government Polytechnic in Karnataka, around
Great
60 kilometers
Great
from Bangalore. This is my third course for this YM. I'm delighted to be a part of the renewable energy sector. And
Yes.
interestingly, we have two branches. One is the alternate energy sources, which covers all these aspects. Okay, so one part I am a teacher, the other part I'm a learner under you.
Yes.
Okay,
Yes.
that's an interesting part of life. Okay, the other thing is I'm sir, we have the subjects of solar, then wind energy and bioenergy. I asked it focus on bioenergy and wind energy. I have 2-3 technical questions. Is it okay if I ask these technical questions?
Please do so. Yeah.
Sir, the one thing we have observed is in the solar energy sector, whatever the panels, everything are there, the efficiency is around 21 to 25% is the
Correct.
maximum. Sir, what are the chances of a higher efficiency product coming into the market?
For a
And
single
interestingly,
junction,
just
so
want to
let me
add.
answer your question first. For a single junction silicon-based solar cell, the maximum theoretical efficiency is around 25%. Okay, so there is very little chance of efficiency increasing if you are looking for a silicon-based single junction cell. The reason why they are favored is their manufacturing costs are significantly lower. If you are going for multi-junction cells or more advanced technologies, the manufacturing costs increase. Okay, so the one of the factors that differentiates renewables from non-renewables is that the resource is cheap. So solar energy does not cost any money. So the efficiency issue only comes in terms of land coverage. So higher efficiency, unless you are looking for a solar cell that is going on top of a car, which is trying to power a car like that. For a stationary system where land is not that much of a constraint, even medium efficiency, low cost panels are preferred because your capital costs are lower, all of those issues come. So that's why silicon has been the preferred option. For space applications, for specific space constrained applications, we can look for high efficiency solar cells. Triple junction solar cells are there, which can go up to 50% efficiency because it captures a larger fraction of the solar radiation and effectively transmits into electricity. But they are much costlier, so they haven't seen significant commercial application. But suppose some company in future creates such solar cells for use in, say, transportation kind of applications, then there might be a market case if it's competitive against other systems. So that would be my answer on that.
Sir, what about perovskite?
Perovskites are increasing in perovskites currently have lower efficiency than silicon cells, but they may go for higher efficiencies in future. So it's one of the most fastest growing research areas in perovskites. New applications are coming. I will have to see what are the theoretical efficiency limits of perovskites. But currently I see efficiencies are growing with every year. So where it kind of plateaus remains to be seen. But it is one of the more exciting new technologies that have come up in the last 10, 12 years.
Okay. Thank you, sir. Thank you, sir.
Thank you.
I have another question I will ask later part.
Okay. Okay.
Okay.
So Vaishnav, you are saying that the amount of insolation varies significantly with latitude. Yes, so that's what I'm saying. The insolation is varying, but the total solar energy per day, you understand, the watt hour per meter square per day, that is reasonably same. Okay. The solar flux is higher. Since the day duration is higher in higher latitudes, the total energy per day is similar. Does that make sense? I think the NPTEL team will have a inbuilt calculator with all the requisite scientific functions. They will be able to tell you the details, but I'm pretty sure that is something that they are going to give you as part of your computer screen or whatever. I'm not entirely sure. Okay. So that is something you can ask the NPTEL team. See, if your numerical is not close to the values given, probably your answer is not right. Okay. If there is a multiple choice questions. So we usually, if it's a question with a fill in the blanks, we give a leeway, a certain plus minus 10% deviation to the correct answer. If you are within that leeway, you will get full marks. Okay, so there is no chance of you making, say decimal rounding and that affecting your mark. Okay, but if your answer is completely wrong, of course, you will not get me. So I am saying that material is not clear in some assignments. If you can clarify where it is not clear, I may be able to help. Kadapa said that. Roughly, one person is asking how much weightage is between theoretical questions and problems. Problems are roughly 20 to 25%. I do not exactly remember right now, but that would be the approximate. Around 20%, I would say.
Just a following question on this.
Yeah.
What is the percentage of MCQs and the other calculation part of it? MCQs.
So that's what 20% is roughly numerical. 80% is theory, 20 to 25%. 80% is theoretical.
The multiple choice are already given, and then we have to take out of it. I mean, choose out of it. So that kind of questions.
Yes. So almost all theoretical questions are multiple choice types.
Okay.
Okay. Because we don't give you short sentences to complete, right? And numerical questions are kind of fill in the blanks type. That is mostly the pattern that I have followed.
Right. Okay. Got it. So 70% I can take it 70% as it like MCQ.
Theory. Yeah.
Okay. Thank you so much.
So Kadapa, you are saying that assignment 3, 4, and 5 are not clear. Is the problem statement not clear or the assignment PDF not clear? So I am not entirely sure what your meaning is.
It means handwriting is not clear, sir.
Assignment handwriting,
Yes, sir.
but it's typed, right? Are you talking about the assignment or course material?
I mean, notes material, sir.
Okay. Okay. So let me see. The theoretical section that I kind of written, that section you are saying it's not very clear, correct?
Sir, can you use calculator in your exam?
So NPTEL team will give you a calculator. So I think they will have a calculator either inbuilt in their computer or something like that.
Okay, sir.
Okay.
Sir, this transcript of the lecture, what are there, will
Yes.
that be sufficient to understand and correlate with the handwriting problem? That is just I'm understanding.
Hopefully it will. If there are
Yeah.
certain issues with the handwriting, what you can do is, let me just go back to my Zoom.
One can go to transcript and then understand.
Yes.
Yeah.
But also one thing you can do is you take a few photos of the sections that you did not understood properly. Okay. And upload it in the Google Help. Okay.
Okay.
Then if you ask questions of if a sentence is unclear or something, I can try to clarify those aspects. So the Pelton turbine nozzles was 4 to 6, not 3 to 5. Yes, 4 to 6. Question that the efficiency of a concentrated solar thermal power system increases linearly with rising temperatures. Answer was false. Let me just open the notes. I think you should be able to. Can I share? I think I can share screen. I hope you can see the screen. So this complete notes are here that I have separated out into systems. So if you go to your solar thermal system, yes. So in this solar thermal system, if you see, this is the expression for efficiency for a solar thermal power plant. And you can see the efficiency is basically parabolic with temperature. It increases, then it decreases. And it decreases because there are radiation losses, this sigma Th to the power 4, that is increasing as the temperature is rising, and that causes a eventual decrease of the efficiency with rising temperature of the hot source. That is why the question, the answer that it was linear is false. Yes, Ashish, your summary is correct. Typical number of nozzles in Pelton turbine is 4 to 6. That is also there in your PPT. See here, the number of nozzles N is 4 to 6. Okay, which assignment is this? I will just check this then.
Sir, this is the assignment of week 3, sir. Week 3 assignment, question
I
number
will
10.
just check with once regarding this, and if there is a error in the answer, you will get full marks.
Yes,
Okay.
sir, right, sir. And options are 3, 5, 7, and 9, sir.
Okay, 5 is correct then. It's 4 to 6, right?
4 to 6, sir. Then 5 is
Yes,
accepted.
so 5 is correct, right?
Sir.
Yeah.
Right. Thank you, sir.
Sir, can I ask a question, sir?
Yes, please.
Again, it is Kishore Kumar back again. Sir, in wind turbine applications, we see that generally in isolated places or high places, we have large wind turbines. Okay. And as you rightly mentioned, the swept area and the wind speed plays a very crucial role. My question is related to what we call it as a micro wind turbine applications, say between 1 to 5 kilowatt. Okay, so what will be the biggest challenge there so that it can be used in common applications like buildings in homes and all these things, residential buildings and all the things?
There has been some work in micro wind turbines. There people would prefer the vertical types of wind turbines. I may not have covered it significantly. The vertical wind turbines you have, instead of the blades rotating like this, it will have this sort of a rotation.
Yeah.
And there the advantage is those are less affected by sudden changes in wind direction. And so because in urban areas, the wind direction is not very certain because of the turbulence, wind shear, and other effects coming from obstructions. Okay. So they have lesser efficiency than a horizontal wind turbine, but they are more robust to changes in wind direction. So if you are interested in looking at the technologies for horizontal wind turbine systems, micro wind turbines, horizontal wind turbines will be something that you can look at. And another advantage is it doesn't require significant controllers. So the horizontal wind turbines, you have to orient with respect to the wind. The vertical wind turbine systems, which are basically using both lift and drag based transfer of momentum, they can work without requiring significant controllers. So the costs are also lower.
So generally the cost will be higher for 1 to 5 kilowatts.
Higher
because
compared
that is compared to the any other system, because what I feel is 1 to 5 kilowatt is most applicable in many of the buildings in residential in cities or towns.
Yes, yes. So,
just like solar applications.
Yes, so wind turbines don't scale as well as solar. The reason is you still need your internal kind of turbine systems to be associated with each wind turbine. Okay, because the rotation has to be converted into electrical energy. So you need a generator system for each system. So it's economics of scale works better for wind turbines than for solar. So the costs will be somewhat higher, but still micro wind turbines are something that is being looked at. So there the vertical wind turbines are often considered the best choice if you want to go for it.
Okay, thank you, sir.
Thank you. the angle between solar radiation and ground. So the question is angle between solar radiation and ground. What is it called? The angle is basically between solar radiation and ground normal. Okay, typically that is what it means, and that is called the zenith angle. For a pure semiconductor, the Fermi level is always in the middle of the conduction band and the valence band. Okay. So it does not change with temperature. What happens is, with temperature, the number of electrons that can be promoted above the Fermi level increases. Okay, but the level itself does not change. The probability, okay, the fill fraction, that expression is dependent on temperature. But EF, the Fermi level itself, has a certain value of electron volts. If you see the worked out examples that I have done, that does not change with temperature. So Amit has asked, what is the role of condenser in a dry steam unit? So the condenser basically condenses after the expansion of steam in the turbine, the low pressure two-phase liquid, two-phase fluid, which is a mix of steam and liquid water, that is condensed and then again sent back into the underground. That is the role that the condenser is playing. Also, from a thermodynamic perspective, in any steam-based power plants, you will also always need a condenser to reject excess heat. Okay. So those are the two roles. Rajesh, I did not understand your question. Most of the data shown in study is
sorry, sir, I'll ask and here. Most of the data shown in the study is like 4 to 5 years old, 2020 something. Okay, it's like not the latest study. So how the answer will be different if we see the present scenario, say 2025 we are into. So how
answers for what? So there are the technologies will not change significantly, but the amount of solar, say the solar capacity and all of those aspects do change.
Yes.
So in the last, say, 5 years, the amount of installed solar energy has increased significantly in gigawatts. Okay. So those aspects will be changing. So for example, how much of the total energy, primary energy is coming from non-renewables? It's still around 78, 79%. So let me so if you are interested in the latest data, let me share my screen once more. The results have changed. It's better. So there is one website called Our World in Data. Because reports usually take a lot of time. So this usually has the most recent data on most of these things. So let us look at solar energy installed capacity. So if you see here, it will all immediately give you up to 2024, the total solar energy installed capacity. And you have a kind of a panel here to look at country-wise figures, etc. So you can see currently in up to 2024, the installed capacity has increased to 1866.3 gigawatts. Okay. Whereas in 2020, it was just 719 gigawatts. Because of this exponential increase, this has almost tripled, not tripled, 2.5 times increase, right?
Right.
And then you can go to China. You can also have this thing and add India here and all of these and look at their growths individually. Okay. So this website is a very useful website to download, say, Excel sheet files, bar graphs, and everything. You can, and it gives you a very transparent idea of the sources. So anything you are looking at, say geothermal or biomass, solar and wind changes the most. Okay, most of the other things don't change as much.
So most of the things will be, we will be getting from here only, from this site.
I originally obtained data from the International Energy Agency. So one of other very common where you can get in-depth data is International Energy Agency. So the global data I will be getting from these two sources mostly. So if you go for topics, you can see energy data is here. So you can see data sets. Some of them are free. Okay, so this kind of gives you additional data sets that you can look at. So let's see.
Yeah, that's more than sufficient to understand, sir.
Yes, yes. So
thank you.
if you are looking at doing a small amount of research on any of these will give you a lot of the data that you need.
Thank you, sir.
Especially for policy analysis.
Okay.
Let's see other questions. I don't think we can share previous year assignment questions. It's with NPTEL anyways. So if they want, they can give you. Not entirely sure how. So we send them to them. It comes in their website. Okay, Vaishnav is asking, since the large hydropower plants are dangerous for people habitation, how can we use the hydro energy for any rural area? Which we can avoid happening in rural community to hydropower establishment. See, this is always a controversial topic. Whenever you have a large hydropower establishment, the certain rural areas will bound to get affected. If it's near a village or something, you will have large scale inundation of sites, and you will have to give displacement compensation for the villagers and all of those things. If you see the entire situation with the Narmada dam project, those were some of the very controversial things. Okay, so what policymakers try to do is bring all the affected people together and give them proper compensation. But these things are, of course, mired significantly in politics. How it should be done is to give compensation and benefits. They can get benefits from the hydropower, some financial benefits that are not only one time, but maybe recurring. Some of the profits may be shared. So there are many ways you can actually give suitable compensation to villagers for the loss of habitat, their lands and livelihood at that location they have been living. Wildlife is more difficult. Of course, moving wildlife is very difficult to do, especially in mountainous regions. When you are building a hydropower, there are problems with ecosystems, earthquake damages, and all of those things. So large-scale safety analysis, ecosystem analysis has to be done, and is done in the more modern hydropower projects to look at the feasibility in all aspects before people can give a go-ahead. But one need to also understand that hydro is one of the sources where you are getting a large amount of renewable electrical energy at a constant capacity with lower intermittency, at least day-to-day intermittencies are much lower. So it's an essential part of the mix. Unlike solar and wind, you don't have like nighttime to daytime intermittency or hour-to-hour intermittency. You have seasonal problems, but that kind of helps in balancing the grid. Possibility of arranging site visits to renewable generation stations through local chapters of NPTEL. This the NPTEL admin will have to take up with people. Of course, for our students, we do organize such things when possible. Not sure what the NPTEL team can do on that end specifically. But you can ask the NPTEL admin to see what facilities may exist on this front, especially for people who have been successful in courses. There have been opportunities to, like NPTEL has good research fellowship opportunities, so maybe they can do something like this also. But of course, there are many courses, so they have to decide on that one. So wind turbines at small scale are inherently costlier. One of the reasons is you will have to have a turbine generation systems, shafts, gears, and everything to convert mechanical energy to electrical energy. Okay. So unlike a solar panel, which just needs a DC to AC transformer and maybe some storage battery systems to look at the fluctuation issues, there is a lot of moving parts in wind turbines. So the maintenance is usually more. Okay. So that is not something that a household can usually manage. All right. So even when you are looking at small scale wind turbines, they are still run by some utilities. Okay. It's not something that you can manage and maintain at home to a significant extent. Also, there is some degree of noise associated with moving blades. So that is also some part of an irritant if you put it in your rooftop. Okay. Yes, large farms, you can put a wind turbine. You have to contact some local wind suppliers. In many agricultural farmlands in Rajasthan, Gujarat, they have wind turbines on their farmland. Okay. Because there the winds are very good. And of course, if you are in Jaisalmer, but in Jaisalmer, we already have a lot of wind turbines. I visited Rajasthan 2 years ago and I saw a lot of wind turbines in many areas around Jaisalmer. So the wind ecosystem is quite well developed there. So you must have local suppliers who are giving those parts, right? So just check with them. And of course, if you have a farmland, then I think it's a good proposition to look at install some wind turbines, go for power purchase agreements with the grid, etc. So what usually happens is if you have a small scale installation of either solar or wind, you can approach your local electric grid person. So whichever is your government electrical energy agency, and then go for like a power purchase agreement. So if you give some energy to them, you get energy financial credits from them. So those kinds of agreements do exist. So You just have to look at the local rules and regulations and incentives there, and it can become a value-added proposition for you. For example, in our campus in IIT Hyderabad, we are developing a kind of a several megawatt scale solar farm, which is going to supply the local electrical demand in our campus. So it's currently being built and expanded. So a lot of the electric power will be coming from there. We have a local kind of transformers and everything is being built. And some of the extra electricity that we can gain, we can sell to the grid. So those kinds of agreements are also in place. So clearly this can be done even for wind at a like a farmland scale kind of. So regarding biogas digesters, there are small companies and startups which can even give you a biogas digester that you can install in your home. I am not sure if it's available in every part of India. We had a small conclave of renewable energy startups at our campus where such products were shown, but they were probably located in Pune or somewhere. I'm sure such startups are there everywhere. You can have domestic or community scale biogas digesters installed for your application. So in our campus mess, we have associated a biogas digester. So a lot of the campus cooking is based on biogas. But even a single home, you can have a kind of a organic dumping area. They give certain containers which where you can put your kitchen waste, and it slowly digests itself inside, and that gas is sourced on a digester. So that can be working for like 6 or 7 homes like that. Well, properly designed digesters will not have smelling issues. So that is of course something that you will have to look at the products that are available and who the users are, and give their get their feedback. And the companies will have the contract of maintaining them or looking at any complaints that may become. So the session will be winding up in 5 minutes. If anybody else have any other questions, this is the time to ask.
Sir, I wanted to ask one question, sir.
Yes.
I was just preparing a topic in which I am planning to just analyze on the dam, sir, the catchment area is there in the hilly areas. Catchment area is there. That catchment area, surface area can be utilized by floating solar panels.
Correct.
And
Correct.
also to some extent with wind turbines, also small scale wind turbines, so that a hybrid system can be made. The base on peak load will be sustained by the dams. However, the fluctuations and other requirements can be met by the solar floating panels and the wind energy.
Okay.
I just wanted to confirm, sir, is there any thumb rule that this much amount of catchment area can only be utilized? Is there any green norms that the organisms living inside the dams will be affected if we'll clear the whole catchment area? Is there any ruling, something like that, sir? What should be my proportion? I should cover for 40% of the catchment area, 60% of the catchment area.
I do not exactly know the policy side of this, but I am aware that floating solar panels technology is currently being used in several dams.
Sir,
So that is something that is already being looked at.
sir.
Specific policy requirements on that will have to be looked at in the local regulatory issues. So I am not entirely sure about the policy aspects of this.
Right, right.
Okay, so in that state, you may have to look at what are the current policies in that.
Likewise, if we consider J&K, sir, the dams in J&K, those can be, the catchment areas can be used for generation of electricity for the soldiers who are posted in the far field areas. That electricity can be straight away forwarded, transmitted to those locations. And the peak load and the generation from hydroelectricity can be given to the citizens of that state.
Yes, I mean, once you have electricity, you can transmit it anywhere, right? So having solar panels or wind turbines, I'm not entirely sure the logistics of floating wind turbines in the land area. Because of course, when you float a wind turbine, the cost is higher. And within land, the wind is somewhat lower, right? So I am not entirely sure whether you can have a catchment area wind turbine economically feasible. I have not looked into that. It may be possible. But floating solar panels is an idea that it has promise, and there are several people trying it out. So that is something that you can look at. But yes, there is an issue of how much can be covered, or what is the how should it be spread out or something? Because if all the sunlight is blocked, the catchment area itself can become healthy in terms of ecosystem wise. So it is something that I also need to look at. So what you can again do is send me something, and I can do a quick research if you can find anything. And if I find anything, I will send you as a PDF or a link like that.
Right, sir. Right, sir. Thank you, sir. Thank you.
Okay.
Sir, can you provide material notes assignment 3 and 4 and 5, sir?
Material means the handwritten ones.
It means handwriting is not clear, sir. Material notes.
Okay. I will check because typing will take some time. Can you,
Okay,
is the entire thing not clear, or there are only some pages which are not clear?
Sir?
Is the entire thing not clear, or some pages and some sentences that are not clear?
Some pages, sir.
Okay. Can you send me an email with which of the pages or a snapshot of that area? Then I can maybe clear it for you.
Okay, sir. Can I share my email ID, sir?
No, you send it in your Google, you have the Google question answer group, right?
Okay, sir.
You know, you are aware of it, right?
Yes, sir. Sir, is there any negative marks in your exam, sir?
There are no negative marks, no.
Okay, sir.
So in the Google groups for this course, you send maybe a snapshot of the area and the places that are unclear. I will try to explain it. Okay.
Okay, sir.
All right. Yeah, please do that, and I will try to answer in 2-3 days. Okay.
Thank you, sir.
Okay. Thank you. Okay, thank you, everyone. It was great to see all of you. and hopefully some of your questions have been answered.
Yes, sir. Thank you so much. Thank you so much.
Thank you. Thank you.
Was it
Thank you,
first
sir.
one,
Thank you
first
very much.
class? Was it the first of this kind of class?
This was the first class. Yes. Yes.
Oh, and when will be the next one?
I will try to have it maybe in another 20 days. I will check before the final exam, maybe 1 or 2 weeks before that, I will try to have.
Okay, okay. Thank you so much, sir. Thank you.
Okay. Okay, thank you, everyone. Okay, I am logging on. Thanks, everyone.